Yes. Friday is a learning enhancement day. And here's what that means. On Friday, you are not required to be at school unless a teacher tells you you need to be here, or you're like, I have a test I want to redo, or you want to come and fix some of the holes in your understanding. For me, the only people I will require be here are students who have missed a chapter test for me. So those people in this class are Chandra. I need you to write me a chapter test on Friday. Cheyenne. If we can get to that point, that'd be great. And that's it.
Oh my God.
Those are the only people who missed the first chapter test. Those are the only people that I'm saying have to be here. I have like 12 in a different math class.
What's happening?
So, what do you mean what's happening? I'm explaining it right now. Okay, on Friday, it's called a learning enhancement day. It means you don't have to be here until unless one of your teachers says you need to be here. So the only students I have who need to write a test, who are missing a test for me, are Chandra and Cheyenne. That's it. Well, technically you have Raj, but he missed the whole first chapter, so you don't have to be here, Fred. I mean, it would probably be a good idea for you to be in the building because you just got here. But what are you doing, on God and Harsh? What are we doing? Comparing jewelry? Okay. So those are going to be who have to be here.
This Friday?
This Friday. Because our report cards are going out next Monday. Yeah. That is an uh-oh for some of us.
Am I cooked?
Could you define cooked for me using old person?
Am I bad?
Am I gonna get 45 minutes out?
It could be better.
Am I
Can you say my
failing?
grades out loud? Can you say my grades out loud?
Yeah, can you say my grades out loud?
Don't look at my computer. Just get over there. We'll do that later. Once I get you guys working on work, if you want to look at your grade, I'll call you up individually. But the short answer to your question, Ethan, is no.
I'm not failing?
You are not failing.
Am I him?
Am I?
You are not.
I said my grade is 50%.
Well, then we did a chapter test, which I then marked.
So, can I see that mark?
I will give them back, not today, but I'll give them back. Okay, so I gave you guys some homework. This is what I wanted you guys to do on Thursday. For this page, you needed to write down the base, the exponent, this thing in standard form, expanded form, and the standard form. Another word for standard form was evaluated. And this whole column required a calculator. And then I gave you one thing out of the row, and I said, okay, well, given the thing I'm giving you, fill it in. So, I want to see where we got. That went halfway, almost here. Gone. Lean back here a little bit. Okay. We got no, not great. Okay.
I finished.
Okay. Yeah, not great. Okay. Need to do over here. Nice. Love it. Page. We just looked at things, so we're on the page of this one. I know you didn't use. You left the class.
Yeah.
We're good. Yeah, we're good.
I forgot it, man. Nice on that. Yeah. First thing I don't have. Yo, don't remind me.
I am out of booklets.
I'm cracking, bro.
Mine.
Class is so dead.
This is the booklet.
That's what I see.
Double-sided, single full punch. Yeah, two-sided. Thank you. Okay, so let's take a look at what I gave you. Lots of you guys just didn't bother to do it. We need to use this time a little bit better, guys. So, it doesn't matter. Like, that's not the point. This is still a class where I have to teach, where you are expected to learn things. You must demonstrate that knowledge if you would want to move on. No. Okay. You know what? I mean, I'll just teach people who want to learn. Move on from there. So here are the answers. Take a look at what you did. I know a bunch of you have marked them already. We talked about negatives and negative bases and exponents and how those things all work. Are there any comments, questions, concerns on anything that you have seen here? Compare what you got with what I got. There should be a straight line there. Okay, I will slide this down. Here we go, to the bottom there. Almost to the bottom. If you guys, for those of you who are just choosing not to use the class time, there's not a lot I can do for you. I'm just going to keep going. I'm not going to give us class time if we're wasting the class time I give you. Are there any questions about any of the things I posted here? Okay, cool. The last one looks like this. Actually, I'll go over to here, the blank page. It's down here at the bottom. It's something to the power of 0. Now, the base is this 1, 2, 3, 4, 5. The exponent is 0. This should be straightforward. You're just reading it right off of here. The base is what is the big numbers at the bottom. The exponent is the small elevated number up to the right. If you punch this thing into your calculator, you get that 12,345 to the power of 0 is 1. If you punch that into your calculator, this is what you're going to get. Now, this thing here doesn't make a whole lot of sense, this empty blank right here. How do you write, okay, Hamid and Abdullah, I'm trying to teach some people. Stop talking, please. How do you write something to the power of 0 in expanded form? Now, if you recall, expanded form was writing out however many bases multiplied this many times. So there is no really good way to write out something to the power of 0 in expanded form. Because if we, so I want you to write something down here at the bottom with me. We're going to write 1, 2, 3, 4, 5 to the power of 1. Because if you recall the meaning of the exponents, the purpose of the exponent is to tell you how many times the thing is multiplied. So my base is still the 1, 2, 3, 4, 5. My exponent now is 1 instead of 0. And so if I want to write this thing in expanded form, I'm going to have 12,345 once. 12,345. It's not multiplied by anything. Squared would mean I would multiply 2 of these things together. To the 1 means it's just there. So in standard form, it's just going to be 12,345. So there is no way to write something to the power of 0 in expanded form. It's just not notation that exists. Are there any questions from the work I gave you on Thursday that any one of you would like me to show you? Maybe it's a question you didn't get done that you think looks particularly hard. Does anyone want to see me do any of these questions from Thursday? Yeah, Hassan. This guy here, negative 3 in brackets, negative 3 over 7 in brackets. Yeah, I can do that, sure. So this is the power expression. And we've got brackets here. When we have brackets, and this is something we talked about on Thursday, the brackets mean that everything inside the brackets, with the exponent on the outside, everything inside the brackets is the base. So my base is going to be negative 3 over 7. And if you remember back to the first chapter, when we have a minus sign like this out in front of the fraction, the thing I encouraged you guys to do was to bring it up and include it as part of the numerator. So I'm going to call this thing negative 3 over 7. Instead of putting the minus sign out front, I'm going to put it up into the numerator. It's the same thing. And now the exponent is just this little number right here. And what that means is I'm going to take the base, negative 3 over 7, and I'm going to multiply it by itself this many times. So I'm going to have negative 3 over 7 times negative 3 over 7 times negative 3 over 7. I have 3 of them, and they're multiplied. Thank you.
I accidentally put the one page.
Oh.
But you have to get
As long as, did it get the back side, or did it?
Yes.
Okay.
All the pages, just.
Oh, whatever. That's cool. Someone gets an extra wide. Okay, so Hassan, are we good with what I've done? Okay, now we're just going to multiply. When you're multiplying fractions is the easiest of all the things you could possibly do with a fraction. You just multiply across the top and you multiply across the bottom, and you're allowed to use your calculator for this. So it's going to be negative 3 times negative 3 times negative 3. Hassan, I saw you with the calculator. What'd you get? That's going to be negative 27 over, and now it's going to be 7 times 7 times 7. With a calculator, that is 343. That is it. You are done. Negative 27 over 343. Yes, Jordan.
I was thinking 10 times 10 would be like 20 and 40.
No, you're adding them.
10 would be 100.
Yes.
Times 100. No, times 10 would be
So you're doing this one up here. Yes, to get to 1,000, multiplying tens, because that's this whole chapter. This whole chapter is all, yes, you need to multiply it 3 times. Good. 10 times 10 times 10, which is going to make the exponent on here a 3, which is going to make this 10 cubed. Very good, Jordan. Thank you. Yes, Hassan. Y to the power of 6. So the only difference with something like this versus something we've done here is that there is no standard or evaluated form because it's not a number, it's a letter. And it doesn't make sense to multiply letters by them, like to actually get a value when you multiply letters. So all you have to do for this one is say, okay, if I have y to the 6, that 6 is the exponent. This is the column for the exponents. The y is the base. And then I'm just going to write it as y times y times y, and I'm going to have 6 of them. 4, 5, 6. And that's all you can do. There is no standard form when you're multiplying letters. Good question. Yes, Jordan.
Some goes for X. Yeah.
That's just like, yeah, the X up there at the top.
X4.
Yes, it is X to the 4. Very good. Some of you guys were asking me about this on Thursday. When you have an X, and I'm using this kind of notation, there will be a different kind of, like the font will be different for the X. So you can see here that this X, that X, that X, and that X all look a little curly. It's a different font for those 1, 2, 3, 4 of them. So that's an X and that's a 4. Very good, Jordan. Thank you. I will try and use the dot notation when I'm using letters, but that's a lot harder to put in a computer. Oh, excuse me. Okay, anything else anyone wants me to see? Hassan, good questions. Jordan, thank you for your input. Okay. Let's do the real deal. Yes, Jordan. One more thing.
So you know that.
This one? Yes.
1, 3. I don't know. 1,
1 over 3. 1 over 3, yeah.
Bracket and 5.
Yeah.
And I have done that.
You did it? Or you didn't do it?
I did
You did do it?
that.
What was your answer? For standard form.
1 over 2 or 3.
That is correct.
Too good.
Yeah, no, that's good. So then there should be a 5 here, and then a third times a third times a third times a third times a third. Very good. And then when you're multiplying, you multiply across the top. 1 times 1 is?
1
Times 1 is? Times 1 is? Times 1 is? Okay, you say it like that's a stupid question, but I assure you, on the chapter test I just finished marking for another class that shall remain nameless, they told me that 1 times 1 times 1 was 3, and 10 times 10 times 10 was 30. So, I mean, we forget from time to time. When you're in the heat of the moment and you're rushing through things, that's why I'm taking the time to be like, okay, what is this? 1 times 1 times 1 times 1 times 1 is 1, not 5.
No, it is 5.
And 3 times, see, and now you're setting yourself up. That's what you're going to lock in. I guarantee, I'm going to be curious to see. I know you're joking now, but you got to be careful with how you joke in math, because you could set yourself up to burn the wrong answer into your brain. I've seen it happen too many times. Like, aha, silly mistake, and then you make the silly mistake. It's rough. Yes, Jordan.
Kind of like the 1 and 7.
Yes, it is like the 1 and 7 one.
1 times 1 times 1 times.
Yes, is 1, not 7. That's good. I guarantee you that mistake's been made.
That would be this.
Yes,
This.
it would be addition. Yeah, you're right. Okay, find me page 4. Lesson 2. There are 7 exponent laws. Your grade 8 teacher tried to teach you 5 of them, I believe. They were supposed to try and teach you. If you were present, your grade 8 teacher would have tried to teach you 5 of these exponent laws. I am going to review 5 and add a 6th. In grade 10, your math teacher is going to review the 6th and add a 7th. I will show you the 7th. It will be optional whether or not you want to use it, but you only have to learn the 6th. Today we're going to do 2. Tomorrow we'll do the other 4, because the first 2 are the most important. The other 4 are based on this one, or these 2. So, buckle up. Here we go. I'm going to spend a little bit of time today justifying where these laws come from. And then once we have a justification for the laws, we're just going to use them. What I'm trying to do is shortcut a whole bunch of work for you guys. But I'm going to show you where the shortcuts come from first. So, there are 2 rules for exponents that you were, had you been present, had your math teacher been doing what they were supposed to be doing, you would have been exposed to last year. The first one is called the product rule. Now, if you recall, product is the word that we use when we are multiplying. A product is the answer you get after you've multiplied a bunch of stuff together. And exponents are all about multiplying things together repeatedly. And so there is a product rule, a rule for when we are multiplying things with exponents. So here's the question. Here's the first question. I'm going to zoom this in so we're all real clear what's going on. I've got 2 squared, and I want to multiply it by 2 cubed. If you recall, when I have, let's ignore this guy here for a second, and just look at 2 squared. What does 2 squared mean? Garrett.
I multiplied 2 by 2.
I multiplied 2 by 2. Very good. So let's put that over here in expanded form. So 2 squared is just 2 times 2. Are we cool with this color? Is it easy to see? Okay. Let's just flip the pen over here and look at the other side. What is 2 cubed? It is, but we're not going there yet. What does it mean to cube 2? I'll say it that way. 2 cubed is 8, but what does it mean? 2 times 2 times 2. Good. So 2 squared means 2 times 2, and 2 cubed means 2 times 2 times 2, and I'm multiplying 2 squared by 2 cubed. So I'm just going to go over here, and I'll put that multiplication symbol in there. This guy here is that guy right there. So now, look at what we've got here. Instead of having 2 squared and 2 cubed, what have I got? Sorry? Eventually it will be 32. But it is not 32 yet. What is it? What do I have? I've got 5 2's multiplied together. How could I write 5 2's multiplied together using this exponent notation? How did we write 5 2's multiplied together? The base is the thing that's being repeatedly multiplied, and the exponent is how many times it's being multiplied. So how could I write this using our exponent notation? The base is 2. The exponent is 5. But look, there's a shortcut here. What could I do with these 2 exponents to get 5? Someone say that again, but louder. Thank you, Liam. I could add them. That's fascinating. If I added 2 and 3 together, I would get 5. Oh, look, that's fascinating. Let's try another one. 7 to the 1 times 7 to the 1. 7 to the 1 means I just have? I have a single 7, yeah. Times another 7. Now, don't tell me that 7 times 7 is 49, even though that's true. How could I write 7 times 7 using exponent notation? I want to use the exponent notation. 7 to the 7? That would be 7 times itself 7 times. 7 to the 2. Thank you, Liam and Dakota. I have 2 of them that I'm repeatedly multiplying together. Remember, the exponent is the number of times these things get multiplied. How do you go, Hassan, from 1 and 1 and make 2? You betcha. 1 plus 1 is 2. Fascinating. I had 2 plus 3 made 5. I've got 1 plus 1 is 2. What does it mean to have x to the 4th? This is going to be similar. You betcha. Dakota said that as a single power, this is going to be x to the 9. You're sensing the pattern. When I multiply bases that are the same, Dakota, what have we been doing with the exponents? We're adding them. If you would like proof of what Dakota has said, she's correct. Here's the proof. X to the 4th means I'm multiplying 4 of these things together. 1, 2, 3, 4 of those. And now I'm going to multiply 5 more of these. 3, 4, 5. And I'm going to multiply the 4 by the 5. It's one long string of multiplication. And if I count out what I have there, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9 of them multiplied together. Nice and easy. So well, let's do one more. Let's take a look at this guy down here. Harsh suggests that there needs to be an x to the 7 and a y to the 4. You are absolutely correct, sir. Because if you look at what's going on here, I'm multiplying those 2 x's, these 3 y's, this 1 more y, and these 5 more x's. When you're multiplying letters together, you can only multiply letters together that are the same letter. So how many x's are getting multiplied in this long chain? 1, 2, 3, 4, 5, 6, 7 of them. So what Harsh did was Harsh looked and said, oh, I got some x's right here, and I got some x's over here, and as long as I'm multiplying everywhere, I can add these two exponents together. And then I've got these y's. Well, I've got 1, 2, 3, 4 of them. This can be my y to the 4th. So I've got these 3 and this 1. We're going to add those together. And that guy, get that guy. So yeah, you guys are seeing it already. The rule for multiplying bases and their exponents. Here it is. Let's write this down. Product rule. When, should be an n, multiplying with the same base, add the exponents. I want you to flip the page into the first 5 questions. Not take you a ton of time to do it. Flip the page. Okay, so do these first 5. 1, 2, 3, 4, 5, go. Flip the page. Do the first 5 questions. On the same page I'm on. I should write down what I wrote down. 5 questions. The first 5, that's it. The first 5, yes, it should be that quick. Yeah, surprise, push that one. There is a single oops. It's a very common oops. So that might not be a bad idea. Use stride and get caught up. Okay. If you're done with the first 5, let me know. Let me check them. Oh, you made the same oops. Go to me. So did you? Nope. So you can use these one law as well. Yeah, no, so if you look at the instructions said to apply rule 1 to 2, we haven't looked at 2 yet, to simplify expressions to a single power. Don't use your calculator. No, you don't multiply things together. Just write them using the exponent laws. And everyone has done the same, everyone who I've checked has made the same mistake on number 5. Jared, what do you got? You also made the same mistake on number 5. I love it. Oh, number 5. Okay, and here's the mistake, guys. If there's no exponent written, the exponent is a 2. No. When there's no exponent written on a number, the exponent is a 1. So on question 5, if I have 4 squared times 4, how many 4s am I multiplying together? 3. So 2 plus 2, 1 is 3. Don't actively try to mess up your classmates. This class is serious, man. Okay. 2, 3. Smart. I like it. Okay. We feel okay? Only the first 5. Okay, so I'll give you the answers to the first 3. Make sure, or for the first 5 rather, make sure we're good. This is what I wanted you to do. Just the first 5. And The instructions say to simplify expressions to a single power. Do not just crank these things into your calculator. So this one should have been 3 to the 6th. Number 3 is 3 to the. Number 5 I already said was 3 to the, or 4 to the 3. Because when there's no exponent written, it's assumed to be a 1. And then this one's going to be 3 to the 4, and this one's going to be 4 to the 5. Cool. Exponent rule 2. And then we're almost done, because that's all we're doing today is 2 rules.
How do you divide?
That is exactly what we're going to look at, Jordan. Here we go. Rule number 2, quotient. If you guys remember your vocabulary from forever ago, I think this was like grade 3 it gets introduced. Maybe even earlier than that, grade 2. Quotient is the word we use to identify that we are dividing. That doesn't mean someone didn't try to teach it to you. I'm learning more and more as I teach longer and longer. And also then, so learn it here now. This word quotient means what is the result when I divide? Usually, unless you're dividing fractions, then the answer is bigger, which is weird, but that's okay. But if you think about what it means to divide, it makes a lot more sense. But we're not doing that. Here we go. Let's take a look. If I have 2 to the 4 divided by 2 to the 1, let's write this thing out as it is written. I'll do the same exercise I did before. 2 to the 4 is, what does it mean to have 2 to the 4? No, it is not 2 times 4, Liam. Thank you, Dakota. 2 times 2 times 2 times 2. Now, 2 to the 1 means I just have a single 2. And what am I doing with these two expressions? Well, I'm going to use division. So I'm going to put my division symbol in there. And, okay, Zach, just put your paper down on the desk and just copy down what I'm writing. If you recall from the first chapter, when we have a string of multiplication and division, we're just going to go from the left to the right. I'm not actually going to do it. We're going to talk about what's going to happen here. I'm going to multiply these two. I'm going to multiply by this. Then I'm going to multiply by this. And then I'm going to divide by this. But when you're multiplying and dividing, you can actually change the order on stuff. I could do this piece first if I wanted to. And in this case, I want to. What's 2 divided by 2? 1. Thank you, Harsh and Garrett. 2 divided by 2 is 1. And so that means this is gone. Because multiplying by 1 doesn't change anything. And so all I have left is 2 times 2 times 2. Well, how could I write 2 times 2 times 2 using power notation, Jordan? Don't say 8. 2 times 2 times 2 is what, Dakota? 2 to the power of 3. So what, if you take a look at the exponents, what did we do with the 4 and the 1? We subtracted them, Jared. Very good, thank you. I subtracted these two exponents to get to that guy there. That is the shortcut that we're going to apply. I'm going to do the next one, but I'm going to show you a different way to write it. Yes?
I was going to say 8.
I know you were.
I was doing 2008.
Yeah, but that's not what if you're going to work ahead, and this is the danger with working ahead. You work ahead and then you think you know where I'm going to go. You got to read the title at the top of the page. It would say standard or evaluated form. It doesn't. It says single power. So I'm going to do this one again, but I'm going to do it a different way. What is another way to write a division statement? There's a different mathematical tool we can use to represent division. No. No. It's everyone's favorite math F word. Fractions. The purpose of fraction. Hamid and Abdullah. One more time, and I'm going to ask you to leave. The whole purpose of fractions is another way to write division. So I'm going to use a fraction notation for this one. I'm going to have 7 to the 5, and I'm going to divide it by 7 cubed. So how we take this and turn it into a fraction, Hamid and Abdullah? Hamid And Abdullah, we're working on this, yes? This piece is your numerator, and you divide it by your denominator. So this is the numerator. And this guy is the denominator. I'm just going to write denom with a period, because denominator is a long word. So this is going to be 7 to the 5. That means I'm multiplying 7 5 times in my numerator. I'm going to divide that by 3 7s. We use fraction notation this time. Now, when all you're doing, yes, Ethan, can you wait like 5 minutes? Because I'll be done. When you are multiplying in the numerator and the denominator, if that's all you're doing, you can start to shortcut this stuff. You can start looking at some of the divisions. Again, this is only true when you're multiplying in the numerator and denominator. If you're adding or subtracting, it doesn't work. But when we're multiplying in the numerator and the denominator, there's a shortcut you can do. You can start looking at individual divisions. What's 7 divided by 7?
0.
No, it's not 0. It's a 1. So let's just cross it out, make it look like a 1. What's 7 divided by 7? 1. What's 7 divided by 7? Thank you. So what do I have left? If I'm multiplying by a bunch of 1s, that doesn't change anything. 1 times 1 times 1 is 1. So what am I left with? I'm left with 2 7s multiplied together. No, it is not 49. Well, it is 49, but it's not 49. Garrett? 7 to the power of 2. Very good. So what did we do? What's a shortcut we could make? So you take a look at these exponents, we can subtract them. It's the same thing we did in the first one. 5 minus 3 is 2. And if you take a look at how this has worked, it's always the first one minus the second one, or the top one minus the bottom one. So someone real quick, rattle this off for me. What's this one going to be? I'll make a note over here on the side. It's always first minus second, or top minus bottom.
X to the power of 4.
It will be x to the power of 4 because 6 minus 2 is 4. Very good. So then this last one here is going to be?
Y to the power of 5.
And just for funsies, we're going to add one more here. Add a question over here on the left. What if it was y to the 4 over y to the 9? Put it on the left here. What would we get? Someone take a guess. It would be -5. It's always top minus bottom or left minus right. 4 minus 5 is -5. Very good. So here's the quotient rule. When dividing with the same base, subtract exponents. I'll go left to right, or top to bottom. So when you're ready, I want you to do questions 6, 7, and 8. There's a trick on question 7. It's the same as the trick on question 5. Yes, Ethan, you go wash them. I want you 6, 7, and 8. Should only take you a couple seconds to do. And then I'm going to do one more example, and we're going to call it. It is 10:30.
How much time?
25 minutes left in class. Yeah, 6, 7, and 8. And remember, when there's no exponent on a number, the exponent is it's a secret number 1. Just like the question I tricked you with on number 5. Take a look at those 3 real quick.
He's not listening.
Hassan's not listening?
He's copying off me. He doesn't know what he's doing.
Liam, why does he not know what he's doing?
He didn't listen.
Ah, yes. Did you do these 3, Shan? Okay. There's a danger when you're working ahead. The danger when working ahead, Hassan, is that you assume what I want you to do. Stay with me.
Are we done now?
I'm going to do 2 more quick examples and then we can be done.
Oh, yeah.
Of increasingly more difficult things. Okay, no, sit down. Number 6, what's the answer? If I want to write this, I want to simplify this to a single power, what's it going to be? 5 squared, thank you, Harsh. Number 7 is 6 squared, or 6 to the power of 2. And number 8 is going to be? Yes, Jared, it is 4 to the power of 1. Okay, I'm going to do 2 more examples with you guys, and then we are going to call it a day. The first example I'm going to do with you is question number 9. Take a look at number 9. I'm going to do 9 as an example. What we're going to do now is we're going to start to combine, because you guys are making this look very easy, and so the only thing I can do then is to actually give you things that are slightly more difficult. So what we're going to do is we're going to start combining, Harsh and Hassan, the rules. So the question like number 9, the first thing you need to do is whenever there's an exponent not written, put it in there. I've got a 3 squared, I've got a 3 to the 4, and then I've got a 3. With that number 3, what is the exponent I could put here? 1. So let's put it in there. It's going to be 3 to the 1. Now, when you have multiple rules, what you need to, this is where students start to get frustrated because there isn't necessarily a right way to do this problem. There's actually like 3 right ways to do this problem. And you have to pick one and go for it. So, when you're presented with something like this, I'm multiplying in the numerator and then I'm dividing by something. What you can do is you can make a choice here. Do I want to simplify in the numerator, or do I want to deal with the denominator first? Because I have the same base everywhere. So someone make a choice here. Do you want me to simplify the numerator first, or do you want me to deal with the denominator first? Liam wants me to deal with the denominator first. So here's what we're going to do. I'm going to take a look at the denominator and just one of the similar pieces in the numerator. And this is how I want you to show your work. I'm just going to look at these 2 pieces. I have a 3 squared, and I've got a 3 to the power of 1. The exponent law we just looked at says when I'm dividing bases that are the same, what do I do with their exponents? I subtract them. So 2 minus 1 is 1. So this piece right here is going to become 3 to the power of 1, and I'm going to multiply that by 3 to the 4. So this is actually now a 2-step problem. I dealt with the first piece, and I'm just going to copy over the times 3 to the 4, the piece we haven't done yet. So now I'm multiplying the same base. What do I do when what's the rule when I multiply the same bases? Yes. Jared and Liam, did you answer the question or were you sighing? Yeah, we're going to add the exponents. So what's this going to be? This is going to be 3 to the power of 5. Cool. Done. I'm going to show you what would have happened if we would have done the exact same question, but the other way. 3 squared times 3 to the 4 over 3. Let's do it again. Except I want to show you what it would have looked like if we'd done it not Liam's way. So first things first, when there's no exponent written, add the 1. And now I'm going to say, I've got the same base in the numerator here. I have 3 squared times 3 to the 4. I can ignore my denominator for a second, and I can simplify the numerator. When I'm multiplying in the numerator with the same bases, I'm going to add their exponents. So what's the numerator going to simplify to?
3 power of 6.
You betcha, Garrett. It's going to be 3 to the 6. And now the part in the denominator I haven't done yet, we're just going to go over 3 to the 1. Now, I'm dividing, and my bases are the same. So it's always top minus bottom. So 6 minus 1 is? Oh, look, it doesn't matter which way we start it. We get the same result.
I think the second one.
And that's great. It does not matter which way you approach it. Either one of these is a totally acceptable way to do this problem. Are there any questions about what I've done here? Okay. Then I'm going to do one more really ugly one for you. I'm going to go over to the side here, and I want you to write down the following question as neatly as you can, because there's a couple pieces to it. We're going to have an 8, and we're going to have an a cubed in the numerator. I want you to write this down for me. Yeah, brand new question. Copy it out. Yeah, please. As neatly as humanly possible, which I know is a big ask for some of us. And in the bottom, we're going to write a 6a squared b times 3a squared b. I want you to write out that question. That's what I like to hear. A man of confidence.
I don't get that.
Here we go. See, but it's this. But Jordan, it's the same as what we've. I want you inside the door. It's going to be the same as what we've just done. We're just going to apply the laws. It's 2 laws, and we're going to start applying them. Jared, that's what we spent the whole first half-hour class doing. When I multiply same bases, what do I do with the exponents, Jordan? I multiply the same base. I blank the exponents. Add. When I divide, I subtract exponents. So let's do this. There is nothing to do in the numerator yet. This denominator looks pretty gross, so let's simplify the denominator. When we leave the numerator alone, we're just going to copy it over. 8a cubed. It's just there. And let's look at how we can simplify the denominator. When I've got numbers and letters, feel free to multiply the numbers together. Hassan, this is your time to shine. What's 6 times 3? Thank you, Hassan. It is, in fact, 18. So I took these 2 numbers and I multiplied them together. Okay? And now I'm going to take a look at the next piece. I'm going to multiply these a's. I got a squared times a squared. When I multiply the same bases, what do I do with the exponents? Add. So it's going to be what? A to the power of 4. Very good, Garrett. And now my last piece here, I've got a b times another b. It's not going to be just b. When there is no exponent written, we got to put the 1s there. And then 1 plus 1 is? So b squared. See, already the question looks a lot better. Well, b times b is 2 b's multiplied together, so it's b squared. I added the exponents. When there is no exponent written, it's a 1. So I put the 1s there, and then I added 1 and 1 and got 2. Actually, I didn't do it. Jared did it, but that's how it was done. And then the last step is to look at these things piece by piece. I'm going to start on the right. Are there any B's in the numerator? Are there any B's up top? No. When there's only B's in one spot, the B's are done. So I want to put my fraction, I want to put my B squared in the bottom. Now I'm going to look at my A's. I've got A's up top and A's down below. So when I'm dividing, because that's what a fraction means, what do I do with the exponents? I subtract, and it's top minus bottom. So 3 minus 4 is? Nope. Thank you, Dakota. It is -1. So we're going to write the base, and whatever you have left goes up into the numerator. So 3 minus 4 is -1, so we're going to have an A to the -1 up top. And now I've got 8 in the numerator and 18 in the denominator. In the first chapter, we looked at what we could do with fractions. What should we always do with fractions if we can? We want them in simplest terms, Ethan, you betcha. So what can I pull out of 8 and 18? I can divide them both, thank you, Liam. I can divide them both by 2. 8 divided by 2 is? And 18 divided by 2 is? 9. And can I reduce 4 and 9 at all? If we go into decimals, which we don't want to do, so the answer is? No. So this then is done.
Where do the letters come from? Are they just like there?
Yes, they are just there.
They don't do anything.
They represent numbers. It's like a friend you've never met yet. Everyone, no, it's not true. Lots of people are friends you haven't met yet. These letters are just numbers you don't know yet. Okay, so. No, there will not be movie time. If you work well for me for the next 10 minutes, I'll give you mind traps. And I bought more candy.
There's 3 minutes left.
No, class goes till 8:55.
8:55?
10:55. 10:55. It's 10:43 and you guys are wasting time. Okay, I would like you to try as much of the rest of these questions as you can. 10 through 22, go for it. Yes, you can do it. I believe in you. You need to try.
I'll give you $2.
Nope, you got to try it. Yes.
Hey, check my The back up, though.